In this video, we're going to go into a little bit more detail on calculating the pH of a solution. So if you'll recall, the definition of pH is negative log of the concentration of hydrogen ion. And remember, hydronium ion and hydrogen ion, they're exactly the same. They're interchangeable. So you might see it one way, you might see it the other. No big deal. Now, before we saw that we could just look at the concentration of hydrogen ion if it was 1 times 10 to a power. So if the concentration of hydrogen ion, for example, was 1 times 10 to the minus fifth, we just could say right away the pH was 5. If it was 1 times 10 to the minus 6, the pH was 6. But what if this number here isn't 1? That's what we're doing here. So let's say, for example, it's the concentration of hydrogen ion is 3.1 times 10 to the minus fifth. Now you're going to have to use your calculator instead of just looking at it and getting the pH. We know it should be about 5, and we know it should be less than 5 because if this number here is bigger than 1, that means the concentration of hydrogen ion is a little bit greater than 1 times 10 to the minus fifth. And remember, the greater the hydrogen ion concentration, the lower the pH. So it depends upon your calculator, but most of you are probably going to do this calculation. Put this number into your calculator, then press the log button, and then press plus or minus. It depends upon your actual calculator though. So go ahead and do that now if you would. Just put this in, take the log of it, make sure you get the right number, and it should come out as 4.508, which ends up rounding to 4.51. When you take the log of a number, if there's once you've taken the log, any digits to the left of the decimal don't count as sig figs. So we had 2 sig figs here, so we have 2 places past the decimal when we take the log. Now you remember there are strong acids and weak acids, strong bases and weak bases, and I've given you in a previous video a list of the strong bases. These are the strong acids. You should memorize these. It's really pretty easy. If you just think about the halogens after fluorine, so chlorine, bromine, and iodine, all those acids with the anions are strong acids: hydrochloric, hydrobromic, and hydroiodic acid. And then there's nitric acid, sulfuric acid, and perchloric acid. There's only 6 of them. There are only 6 acids that are strong acids. If it's an acid, and you know it's an acid when you look at the formula because it starts with a hydrogen, or if you're looking at the name, it has the word acid in it. If it's not one of these 6 and it's an acid, then it's a weak acid. Now, if you have a strong acid, then the concentration of hydrogen ion is the same as the concentration of the acid, unless it's sulfuric acid, which has 2 protons, but we're not going to get into that. And so what that means is if you're given the concentration of a solution of a strong acid, like say nitric acid, for example, if the concentration is 0.023 molar nitric acid, you know that the concentration of hydrogen ion is also 0.023 molar, and to find the pH of that solution, all you do is take negative log of 0.023 and gives us 1.64. Remember, the 1, because it's to the left of the decimal after we've taken the log, doesn't count as a sig fig. So that we had 2 sig figs here in the 0.023. We have 2 places past the decimal once we take the log. So it's the same thing as before. It's just that sometimes you'll be told that the concentration of a solution of a strong acid, what it is, and then you get the pH just by taking the negative log of that number. Now we can go the other way too. If we know the pH, you can also calculate the concentration of hydrogen ion or hydronium ion in that solution. And this is the definition, so you should memorize this. The concentration of hydrogen ion will be 10 to the minus pH if you know the pH. So all you do is you put the pH into your calculator, make it negative, and usually it's going to be 10 to the x on your calculator. So what is the concentration of hydrogen ion in a solution whose pH is 9.72? Remember, now this number here, it's a pH, so it's already had the log taken of it, which means that this 9 does not count as a sig fig. So this has 2 sig figs in it. So we take to find the concentration of hydrogen ion, because we know the pH, we just take 10 to the minus pH. 10 to the minus 9.72 gives us 1.9 times 10 to the minus 10th. And that's all there is to it.